Hello everyone, and thank you for joining. Today I want to walk you through a recap of our journey building Orderit, a complete AI-powered food ordering application using Monstack. Over the past several sessions, we have gone from a blank folder to a fully working full stack product, one that touches everything from database design to payments to artificial intelligence. That is not a theory courses. Every concept we have covered has gone straight into a real working app that can you put you on your resume. So let's dive into the roadmap. Internship overview. Let's start with the internship was actual designed to do. First, it is a zero to hero program. No prior experience was assumed. Every concept from the very first line of the code was explained simply and built up gradually. Second, this is practical first. We did not spend weeks in theory. We built an actual product, session by session, so that the learning stuck. Third is the full coverage. We touch every layer, setup backend, front-end database, AI integration, and eventually deploy and documentation. The entire cycle of a real product. And finally, it is free and certified. No cost for the sessions, the certificate, or the offer letter. All that was asked in written and consistency, showing up, practicing, and asking questions. But by the end, every learner walks away with a portfolio layer ready project they can actually show up in the interviews. The MAN stack. Now let's talk about the technology itself, the MAN stack. MAN stack stands for MongoDB, Express, JS, React.js, and Node.js. Four different tools, but they share one enormous advantage. They are all built on JavaScript. That means, as a learner, you do not have a context switch between four different languages. So you can one language and use it everywhere, from the database all the way to the browser. Let's break down what each piece actually does using a simple mental model. MongoDB is like a digital filing cabinet to store your data flexibly in collection without demanding a right table structure. Express.js, the toolbox for building the server. It handles routes, request, and response. Next is React.js, the entire design. It is responsible for what the user actually sees. Node.js, it is the engine. It's what allows JavaScript, normally a browser language, to run on the server. Together, these four pieces form a complete modern application stack. And that's exactly what we use to build Order It. Next slide is frontend and versus backend restaurant analogy. To make frontend and backend really click, we used a restaurant analogy throughout the internship, and I think it's worth repeating here. Think of the frontend as the dining area of a restaurant. It is what the guest actually says and interacts with the menu, layouts, and the design, the ambience. In our stack, that's built with the HTML, CSS, and React. That focuses here is entirely on user interface and user experience. The backend, on the other hand, it is the kitchen. There is the real works happens. Order and proceed. The data is stored, passwords are checked, logins are validated. None of this is visible to the guest, but without it, nothing on the menu would ever actually arrive at the stand table. We built this Express, JS, and MongoDB. A full stack developer then is someone who comfortable managing both the dining room and the kitchen, and that's exactly the set this internship was designed to build. Then AI, the brain of our app. Now, what actually makes Order It more than just a standard food delivery clone? The AI layer. We treat AI as the brain of the application, the part that makes intelligent decisions instead of just following static rules. And importantly, we did not have to build any AI models from scratch. We simply connect to existing pretend AI models through APIs, meaning you do not need a deep AI or machine learning background to add real intelligence to your app. Four AI features went into order. 1. AI generate description instead of an admin reading every disease description by hand. The AI generate an appealing description just from the dish name and price to its review summarization instead of a user scrolling through 1,000 reviews. The AI consistence them into a clear positive and negative text. 3. Smart recommendation based on the mood, budget, dietary preference. The AI suggests dishes very similar to how Netflix recommends what you watch next. And 4. Natural language search. A user can type a plain English request and the AI converts into actual structured search filters. This is the layers that turns a standard keyword app into the something that feels genuinely smart. Then core app features. Let's ground this in the actual features we built into the product. Users can browse and search real-time restaurant listing, complete with menus, reviews, rating, and sorting options. They can manage a live cart, adding item, increasing or decreasing quantities, or removing them entirely. They have full account management, registration, login, profile editing, and order history. Payments are handled through Stripe test environment, so the transaction feels completely real without any actual money moving. And on the other hand, they are full admin panel where restaurants owners or admins can add and the update restaurants and the menu item, complete with a generated description. Put together, this is a real end-to-end product, not a toy demo. Then Beckett Foundation. Now let's get into how we actually build this. Starting with the backend foundation, we structured the whole application around three-tier architecture. The presentation tier is our React frontend. The application tier is Node.js and Express, handling all our business logic. And the database tier is MongoDB hosted in the cloud, so it is accessible from anywhere. To get the package running, we used npm init -y to generate our package.json file and then installed our four essential package Express to simplify our server and API creation, Mongoose, which acts as the interface between our node code and MongoDB, handling schemes and CRUD operation course, which is critical whenever your frontend and backend runs on the defined ports. Without it, the browser blocks this cross-origin request. And .NEF, which lets us securely manage things like API keys, password through a separate .env file instead of hard coding them into our source code. We also introduced the concept of middleware function that runs between the request coming in and the response going out. Think of the middleware as a security guard checking things like authentication before anything reach your actual business logic. Next slide is secure user authentication. Once our server was up, the very first real features we built was authentication. because almost nothing else in the app works with knowing who the user is. We followed four clear steps. Step 1. We designed the user schema: name, email, password, phone number, and avatar, along with proper validation rules like required fields and uniqueness on email. Step 2. Bracket hashing. This is non-negotiable in any real application. Passwords are hashed before they are ever saved to the database. Plain text passwords are never stored. Period. Step 3. JWT tokens or JSON Web Tokens. When a user logs in successfully, we use a signed token that proves their identity for a set period, typically 90 days in our case, so they do not have to log in on every single request. And 4. We tested every one of these routes in Postman before ever touching the front end to make sure the backend was rock solid on its own. This flow schema has in tokens testing is really the backbone of secure authentication in any modern web application. Next slide. The modeling data. With authentication working, we moved on the modeling the actual business data, restaurants, menus, and food items. The restaurant schema holds the name, address, and the rating along with the JSON location field, which we indexed using a 2D sphere index so we can efficiently run location based queries like restaurant near me. It also holds arrays of the reviews and images. The menu schema is deliberately lightly weight. It just holds a category like breakfast or lunch and arrays of reference to food items and a reference back to the restaurant it belongs to. And the food item schema holds the name, price, description, rating, and an array of image objects. The key design decision here is reference and not the duplication. Rather than repeating restaurant data inside every menu or food item data inside every menu, we just store an object ID reference and then use Mongoose populate method to pull in the full related document only when we actually need it. This keeps our database clean, consistent, and much easier to maintain as it grows. Then next slide is next we tackled something every really commerce or food delivery apps needs payments, and for that we integrate Stripe. The flow is simple to describe but powerful in practice. A user adds item to their cart, and the backend builds a Stripe checkout sessions from that cart data. The user is redirected to Stripe secured checkout page, and finally they land back on our site, either a success page or a cancel page depending on the outcome. If a few critical details here. The secret API keys never leaves the backend. It is stay in our .env file. Only the publishable key is ever sent to the front end. That separation is fundamental security practice. We also had remember the Stripe experts amounts in the smallest currency unit. So for Indian rupees that means paisa, which means every price gets multiplied by 100 before being sent. We configured shipping option to delivery charges, estimate delivery windows, and which countries we'd expect orders from. And wrapping the whole payments controller was our cache async crusader. middleware so that if anything goes wrong with Stripe APIs, the app fails gracefully instead of the crashing. Next slide is React building the interface. With the backend solid, we shifted focus to the front end, and that starts with understanding React's core building blocks. Components the reusable piece of UI. Think of them like furniture pieces you can place anywhere in our house. We write them using JSX, which blends JavaScript and HTML-like syntax together. Props let us pass the rhythm, the parent component down into a child component, like giving instruction to an entire designer about the what color the wall should be. State in how we track dynamic changing in from with a component within a component. For example, a likes counter that grows up every time a button is clicked. We manage this the React use state hooks. And the virtual DOM is the React secret to performance. It's essentially a blueprint of UI and lets React update only the parts of a page that actually changed instead of reloading everything. These four concepts components, props, state, and the virtual DOM are really the foundation everything else in the React is built on. Next slide is state management with Redux Toolkit. As our app grew, managing data with just computer level state was not going to scale. So we introduced Redux Toolkit for the global state management. Here's the flow end to end. A component dispatch an action, say get all restaurants. That action triggers a slice which calls our backend API. The backend in turn talks to MongoDB and returns the data. Once the data is come back, our Redux store updates and UI automatically re-renders to replicate the new information. A few key concepts made the manageable. The store in the single center holder of application data, like a restaurant manager who knows everything happening across the whole business. Slice break the store down by features. We had a restaurant slice, a user slice, a cart slice, each building its own state and reducers together. And the reducers themselves are split into request, success, and failure states. So we always know exactly what the stage an APS calls is in. We also used React use effect hook to automatically fetch the data the moment a component mounts. So the UI feels alive and populate from the very first load with no manual button click request. Then wiring it all together. Of course, none of this work useless. The frontend and backend can actually talk to each other, and that's where a couple of final piece came in. First, the white proxy. Our frontend runs on the port 5173, our backend on port 808. Inside the fed.config.js, we set up a proxy so that any request to slash API gets automatically forwarded to the backend, which completely sidesteps code issues during the local development. Second, React Router, which gives us power single page application navigation. A browser router component watches the URL and whenever it changes, React Router renders the correct component without ever triggering a full page reload. We compare this to a mall directory. It guides visitors instantly to the right store without them having to leave the building. This is what let us route between the restaurant list, the menu page, the cart, and the user profile. all inside one seamless experience. Next slide is learning support and structure. Before we wrap up, I want to acknowledge the support system that made all of this possible. Every sessions, every code sample, and every set of slides lived on our LMS portal. So nothing was ever lost to hard to find. Our discussion forums were open at all times. Learners could post doubts, share screenshots, or upload files and get help without waiting for the next live sessions. Quizzes refinement to trigger concepts things like JWT and HTTP methods in short interview style format. And the last slide is so to bring it all together, what the big lessons from this internship? One, a single JavaScript stack MERN takes you from the database all the way to be the browser with zero context switching between language. 2. AI generation through the simple APIs at real intelligence, description, recommendation search without requiring any deep AI experience. 3 is clean the architecture. 3 is security has to be considered at every layer. Hashed password, JWT sessions, environment variables, and keeping secrets to on the backend only. 4 is clean architecture matters. Our consistent flow of schema, the controller, then route, then app is what kept going codebase. Maintainability instead of tuning into a mess. Fifth is Redux and React Router or what transform a static disconnected UI into a dynamic data driven single page application. And last finally is the result of all of this is a complete portfolio ready AI powered food delivery app built our first principles by people who may have started the internship with zero full stack experience.